So let's solve this question. Let f of t be a real valued function whose second derivative is positive for minus infinity less than t less than infinity. Which of the following statements is always true? Nice question from calculus. F of t has at least one local minimum. Look, first of all, we'll discuss some things about the function. Given f of t is real valued function, correct? So f of t is real valued function for minus infinity less than t less than infinity, right? This is what you have given, and second derivative is positive for all values. Okay, so f double dash of t is always greater than 0. So what does the statement second derivative being always positive tells you? Okay, if second derivative is positive, look, for example, if you just see this means that this implies as t increases, f dash of t also increases, f dash of t also increases, correct? This is what it tells you. So as the function is means as the t is increasing, means on the real axis of t, means if you take t axis, as t is increasing, definitely the slope of the function also increases. Okay, so this implies the slope of the function increases with t, of course. Okay, the slope of the function increases with t. Now when this is continuously increasing, when the slope is continuously increasing, then ultimately we cannot have any local maximas or local minimas actually, correct? We can have maybe one global minima if possible at some location where the function is starting at minus infinity, but after that point when the function is continuously increasing, and this implies if f dash of t is also increasing, that means as t is increasing, the function increases very rapidly. Okay, that's what we mean. So this implies the function cannot have any local cannot have any local maximas or minimas, any local maxima or local minima, because obviously, for example, if you take e power x function, okay, when you take e power x, if this e power x is continuously increasing, then this function do not have a local maxima or local minima, right? So to have a local maximum, what should happen? The function should go up and again it should come down. If function is going up and coming down, then at some point second derivative has to be equal to 0, but second derivative has to be negative. So but this is not the case. Similarly, when this f double dash of t is positive, then you may feel that we have a minima, but this minima is not any finite or means basically not any fixed value. It can be at some location minus infinity, that's it, because then after the function continuously keeps increasing. Okay, it has a positive slope, of course. So whenever you have this function cannot have any local maxima or local minima. So let's see the points. F of t has at least one local minima, so this point is wrong. F of t can't have two distinct local maxima, cannot, of course, yeah, this is true because if they are talking cannot. Okay, f of t has at least one local maxima, no, definitely it is wrong. As I told you, when the function is continuously increasing, like exponential functions or you take log functions, whatever, then when they are continuously increasing, it cannot have local maximas or local minimas. Okay, now coming, the minimum value of f of t cannot be negative. No, it can be negative. The reason is, like for example, f of t, what they tell you, the minimum value of f of t cannot be negative. It can be negative actually. See here, I can show you. The minimum value of f of t can be negative actually. Like normally if you go for if you go for a subject called fluid mechanics, we have some particular fluids which exhibit this behavior actually. Okay, this particular behavior where when you increase the particular parameter, the function increases much faster, keeping the second derivative always positive. Okay, in such cases we can have the minimum value of f of t can be negative, of course. Example, you take a function like this, t and f of t, of course, and you draw this function with increasing slope. Okay, so the slope always increases with t, so the second derivative is positive. Of course, the means as t increases, f dash of t also increases definitely. So this is what, and here you can see it has a minimum value. Okay, so the minimum value of this f of t can be negative, which is like this. Okay, so this is 0, of course. So these points, all these points are having negative value of the function. So that's it, only this statement is correct. So this statement is also wrong again. Okay, it cannot be it can be negative actually. So B is the only statement. So these are some conceptual understandings from the graphs. Okay, it's a nice question actually from calculus that was asked this year. Thank you.